Okay, I'm going to make two quick videos here, and they are related to the quiz in the assessment section of Module 6. And just want to show you a couple of the problems, and there's two in particular that will cover a lot of ground for us. I just want to show you how to work uh, two examples, and it will be helpful for you as you get ready to do the quiz part for this. This is all, of course, related to Chapter 7. So I bring this in here, and I'll just try to do this live instead of waiting. Okay, here we go. All right, so here's one type of problem that you will see on the quiz. All right, and so as you look at it, this is actually right out of Bolsted's circuit analysis book, and it's figure 19.1, chapter 19. And what you're dealing with there is, you've got these, what we call traditional circuit analysis problems. And as I look at this problem, I can see that I have the following components. I have a 10 ohm resistor, a 15 ohm inductor, and a 2 ohm capacitor. Now, what I didn't do here, and because I know you've been away from this for a while, and at the same time too, I also realize that there's certain areas that you know you may have been rushed through in terms of things, but what I did here, instead of having you go through this calculation, which well, wait a minute, this calculation for this type of problem where you would have 10 plus j 15 minus 2. Okay, and you're trying to get the total impedance, and so that would be 10 plus j 13 in rectangular form, and then from there you get a value that you can use to do the calculations. So let me run that through the calculator for you. So when I do the calculation, so this is the impedance in rectangular form, and then in polar form, it would come out to be 16.4 at an angle of 52.43 degrees. All right. So you've been away from that for a while. So what I did is I gave you that value. All right. So I didn't require you to come up with that particular number. So what the question is, and the reason that these problems are on this quiz is the way that we have approached this is through power triangle, right? And not worried about angles and phase angles and so forth. All right. And so if we know that that's the case, and so what do I know with this problem? Well, I've got 20 volts at 30 degrees. I also know, okay, so that would be my voltage, right? I also have my total impedance given as 16.4 at an angle of 52.43 degrees. And I also have current given as 1.22 amps at an angle of minus 22.43 degrees. All right, so um, with that, with all that given, what I'm telling you is you can work this problem and not get into this world here. It's really very simple. And if you know that, of course, it's simple if you know that, right? And so I can do this problem two different ways. All right. One way that I can do it, I'll do it in red, is I know that the total power, the power is going to be, what do I know? I know the voltage and I know the impedance. So it would be E squared over Z. That would be 20 squared over 16.4. And if I run those numbers through, if I do 20 squared, that's 400. I divide that by 16.4 and I get 24.4 volt amps. Okay, so that would be the answer that I want to indicate on there. All right, so again, point being, we don't have to concern ourselves with angles on this stuff. You know, it's not something that we need to do to be able to solve the problem. Another way I can work this is I know that power is equal to the current squared times the impedance, right? Or current squared times resistance back in that old world. So again, if I know the current is 1.22, which is given to us here, offered that to you, and I square that value and I multiply it by the Z number, the impedance of 16.4, I'll also get 24.4 volt amps. Okay, so anyway, just want you to use what information you're given and don't worry about what you don't need, and that will help you with these problems. Now, I'll make one more of these, share it with you.